to our last case presentation. Martin, are you there?
Yes, I am. Let's see
Great.
if I, let me see if I can. All right.
You're good to go. Excellent.
Thank you. So I see now I have 5 minutes left. I'll be quick.
No, I'll give you 3 more. That's fine.
That's very kind of you. Right. So hi everybody. My name is Martin Rugfeldt. I am the CEO and founder of Sentian .ai, and we help large companies transform themselves with AI. And for those of you who do not know us, we are in what we say ourselves is a leading industrial AI solutions provider. I hope the presentation will show that we are. We have a very experienced set of AI experts in the team, and we have an ambitious roadmap, both when it comes to the product development, but also research in AI. And we've managed so far to get to several technical breakthroughs. I'll tell you a little bit about some of them. And we've also been recognized for some of this technical and business excellence. And most importantly, we have some very, very good customers. What I'll talk about today is a case of energy optimization, and it's using a new type of AI called MBRL. So you'll hear a little bit about that. Let's see here, and you also see touching upon the way to the roadmap to intelligent autonomous solutions. Just some words about Sentian. We have 2 products, Icon and Sentian Planner. We're actually in the process of changing names on them, but I think they should be consistent here. And I'm having issues with reloading of my pages here. Hope, God. Well, hopefully you can see most of the page. It didn't load fully. So Icon, it is really a new generation of automation and control optimization solution, and it's based on this new generation of AI. And it's a fairly unique solutions in the marketplace with the technology it's using. And it makes it possible to adapt more to changing environments, tackle more complicated processes, and create higher flexibility. One can actually liken this more to an advanced process control solution. So it's an modern AI-powered advanced process control, or an APC, but it can also be applied to a range of other situations. And we apply it to manufacturing and machines, where you can do a lot of different things with it, to process optimization in the process industry. That's where my case is today, and also in the interaction between man and machine, and learning from operators, and tuning and calibration. We also have another product in the area of Sentian Planner. It's a product that deals with planning, supply chain, and logistics optimization. It's based on technical breakthroughs we did there too. And we did that as we broke the current world record in nonlinear optimization in the QAP category back in 2019. And we apply this to planning, supply chains, and logistics, and really optimize those processes in an effective way. But I wanted to talk about the case, and also about the technology around that case, and also about the general industrial challenges associated to this. And if we look at those, we see that the industry, I mean, it's a high dimensional place. It's a lot of non-linear processes, while current automation and control systems are well, they're linear most of the time, and they're quite reactive rather than being proactive, and their standard protocols are a bit passive, if you put it that way. And there tends to be overshooting, oscillations, or you can maybe set them to undershoot in order to deal with some of the issues that are existing in these processes. So there's a range of different challenges associated to the nature of the industry and the automation and control systems. And some of the problems that they're trying to address, that they need to address with these systems, is variations in input parameters, deviations in production quality and scrap levels. They can be very slow to adapt to changes in the processes because they're reactive rather than proactive. And there's speed versus quality trade-off. You may lower the speed in order to not jeopardize the process. Robustness issues, dependency on machine operators, have to be really experts at the machines. You can see big difference between different teams depending on their experience and how they work with the systems. So that results in lower yield, higher cost, higher emissions, higher scrap, but also lower quality and operational issues. So we see this as really the need for a new type of system that can deal with this. And well, we have that. We have a new generation of AI to deal with this called model-based reinforcement learning. We've been trying a lot of different technologies when it comes to that, and we didn't find the right one that could really scale when it comes to this new generation of process control and automation optimization. But when we found model-based reinforcement learning and started building with it, we really realized that it really worked. So it has some really great advantages. You can build a real-world representation, what's called an inferred dynamics model of the data that comes from the process. There's continuous learning. It creates scenarios of how the process looks, so we can explore the optimal set points. It is also very sample efficient, so it can work with little data, and it's often not much data, and there's changes to the processes, and we can deal with that, and we can do fine tuning, and we can get very good stability on this. So that's a little bit about the challenges and the solutions on a general level. But if we look at the case here, it's in chemicals, it's production of PET plastics, PET granulates, very large production of that. And they also spend a huge amount of natural gas to heat the processes related to it. And the general pain points of the chemical process industry is really that it's very large scale and it's complicated and complex. And there is variation due to the environment, is the temperatures, the humidity, and things like that, and so on. And it's very energy intensive, and hence also has a large impact on the environment. And these are pain points, but also opportunities. If you can get these right, you can really do great things. And in this particular case, we are looking at the energy optimization of the burners, it's very large cost, and it has a large environmental impact. They're using several heaters here, and that can work alone or together, and it heats several processes. And with this, they also have to take care of the redundancy, so there's multiple heaters for that. And then as a result, well, not as a result, but the excess heat is obviously very costly. So if you didn't have to burn it, it shouldn't be burned. The process is controlled by DCS. There are other systems associated that collects data, and the data is also available in the DCS. So we connected to both of these systems for various data points. And this process is actually varies. Well, the needs really from the various reactions vary. So we have to go up and down in how much energy that is produced and for heating. And today the production is not always optimized. So that's what we're trying to really solve in this case. And we came in with our Icon product, and we connected it to the systems. And so it's really integrated directly to the control of the heating part of the system. And we used their existing data set. They had a lot of data in this case. We don't always need huge amounts of data, but in this case, they had a lot of good data. And we then predict the optimal set points for the desired outputs, and we can do that very well. And that reduces the variation, and it reduces, more importantly, the amount of energy that is being used in the process for heating. And I'm okay. So this unfortunately doesn't load properly. Here's a picture of the system. So Sadly, you can't see that. I just wanted to finish off by saying it's goals oriented. So the operators can, want to control the process by just dragging a variable, saying we need to produce more, or we need to save cost here, and they can do that. And that becomes a very intuitive way of working with the process. There's very little oscillations in it. It's very quick to get to the correct set point. So it's very efficient in this type of process to reduce the energy. So as soon as you don't need heat, you can deal with that. And it really works by putting up a scenario of what's going to happen in the future. So it looks long into the future to do that. So I won't go into more detail. We're currently at around 5% improvements. We're quite early in the project. We hope to get higher. And yes, that was it. Have you got a challenge? Let's meet. Book a demo with me or so.
Perfect, Martin. Thank you so much. Always a pleasure to have you, and always impressive to see your cases